Actually, this is very much important question. This is a very much important question, and it is taken from S.C. Verma, Concept of Physics. Very good question. It is telling that some equipotential surface are shown here. These are equipotential surface because at each point, at any point on this line, on this surface, potential will be 10 volt only. And for this line also, at each point, at any point, potential will be 20 volt only. Here, at each point, potential will be 20 volt. At each point, potential will be 40 volt, like this. So, it is telling that they are equipotential surface. Question is that what can you say about the magnitude and direction of electric field? We have to comment on the direction and magnitude of electric field. So we know that by a concept, we know that electric field is always, yesterday I have taught you that if we have this type of field lines, then we have electric potential surface like this, perpendicular to field lines. Okay. Now, if we draw perpendicular here like this, potential here like this, perpendicular here like this, all are perpendicular like this, perpendicular to this line, perpendicular to this, then this will represent electric field lines. What it will represent? Electric field lines. Okay, and these are EPS, equipotential surface. So now we have to find what will be the magnitude and direction of electric field. We know that E is equal to minus dV by dr, that we know. Or we can say that it is equivalent to delta V by delta R, change in voltage, potential, or change in the distance between the two potentials. So what is this? It is given that potential is changing from 20 volt to 20 volt. Finally, it is 10 volt, and initially it was 20 volt. So we can write final minus initial 10 minus 20 like this. Okay, one minus sign here. Now we are telling that delta R, we can say that delta R means this distance, delta R, we can find it by this. This is 10 centimeter. Considering this triangle, it is given, it is 90 degree here. We can see that it is 10. It is, we have to find this angle. So we take sine of this, sine of 30 degree. Sine of 30 is equal to perpendicular by hypotenuse, that is 10. We can write here delta R is equal to 10 into sine 30 will be 1 by 2. That means 5, and it is 5 centimeter. We can write like this, 5 into 10 to the power minus 2 meter. We will write here 5 into 10 to the power minus 2. We will get from here the magnitude. Now we have to think what will be the direction. How we have determined that direction will be in this direction. It can be in this way also. So yesterday I have taught you in the direction of electric field, if we are moving, potential decreases maximum. You know, in the direction of electric field, potential decreases maximum. You can see in this direction, if we are moving, in this direction we are moving, in this direction we are moving, we are seeing that potential is decreasing from 20 to 10. We are moving in this direction, then potential is moving, decreasing from 30 to 20. That means electric field will be in this direction only, because we can see that electric field is in this direction because potential is decreasing in this direction only, from 40 to 30, from 30 to 20, from 20 to 10. So we determine that electric field direction will be this, and we can find it by using some trigonometry like this. Now how we can find? We can take a value like this. We will use a vector concept. Vector by vector we know. By vector we know one concept. Let's use vector concept to find direction of electric field. We can say direction of electric field, regarding direction of electric field like this. Okay. Now for electric field, what we will take? We will draw, we will take this angle. Let us consider this angle, this is same angle with this, same angle here. So because it is figure is very much looking very much tight here, so we are taking this. So this angle will be, we know this is 90°. So total angle will be 90 plus 30, 90 plus 30, that means 120°. Okay, now we will write our answer like this. How we will write our answer? We will write our answer like this, that value of electric field is, value of electric field is this much, value of electric field is this much electric field. We will get some electric field, this much Newton per coulomb at angle of 120° from x axis, that is this. Okay, this is a most important question, remember. Okay,